Surface problem on martial mix design. In this math, we are given the percentage of uh, different sorts of ingredients and its specific gravity. I will say a little bit about them. If your course aggregate is retained on uh, four number sheet, we call that course aggregate. If it's retained on uh, if it passes four number shape, we call that fine aggregate, but retained on 200 shape. But if your aggregate passes 200 shape, we call that mineral filler, and the other one is asphalt cement. So let's call the percentage, uh, P1, P2, P3, and specific gravity G1, G2, G3. These annotations will help us later. Well, let's find out the specific gravity of aggregate. So what do we mean by that? We mean that we have different sorts of ingredients, and amongst them we have three sorts of aggregate, that is coarse aggregate, fine aggregate, and mineral filler. And these three ingredients have different sort of specific gravity. We will find out a single one that will represent the aggregate, and for that we have a formula, that is we call that GSB for bulk specific gravity of aggregate, and we have a formula, interesting formula, that is P1, which is this, P2, P3 over P1 over G1, P2 over G2 plus P3 over G3. Now you can use 56, 30, and 7, but there is a problem. P1, P2, P3 is the percentage of uh, aggregate or ingredients of the total percentage of aggregates, not considering asphalt cement. So for that we'll have some correction, that is P1 will be 56. We got 56 out of 56 plus 30 plus 7. For this 3 is 93. So we got 56 out of 93. But if we change it for 100, we'll get a different value, that would be 60.21, is the percentage. Similarly, you will get P2, that would be 30 over 93 multiplied by 100, and you'll get a value of 32.26. And you'll get P3. For that you have 7 over 93 multiplied by 100, and you'll get a value of 7.93, if I'm not wrong, or 7.53. Yeah, it's 7.53. Well, now you know the value of G1, G2, and G3. You can find out the value of GSB, and that would be 3.07. So this is the thing. One more thing, that is to find out the optimum bitumen content, you need a few parameters, like you need weight, and then we call that void of air of compacted mix, and void of uh, airs in mineral aggregate, void filled with asphalt, and then you need flow value, you need Marshall stability value. So these are the six parameters you need to find out the optimum bitumen content. So in this math, we are finding out the value of BA, BMA, and BFA, and you get these values of flow index and Marshall stability value from your experimental test, and you just find out the unit weight, dividing the total weight of your specimen by its volume. So we are learning the procedure. So next thing is that you want to find out the value of what do we say, VMA. Sorry, VA is actually VA, a percentage of bars in a compacted mix. So let's find that out. let's say this is our second problem B, and for that, it's actually the percentage of air voids compared to the volume of total mix, not just the aggregate. So keep that in mind. We have different air voids. It's for mineral aggregate and it's for compacted mix. We'll find out for compacted mix. It is actually these. Let's try to learn from this. So you have air, you have asphalt, and little bit of asphalt being absorbed by your aggregate, which is this portion, and this total portion is the volume for your aggregate. So what do we mean by VA? We understand that if you take the total volume, which is VMB, and you take the volume of air, which is VA, and you multiply it by 100, so this is your percentage of air voids, and we're finding that here. And for that, we have a formula that is, for BA we have a formula that is GMMM minus GMB over GMM. From a specific gravity, you can find that out. So GMM is given. GMM is the maximum specific gravity of paving mixture, and it is 2.478. But the thing is, what is GMB? GMB is pretty simple. That is the specific gravity of your specimen. Not it's not the specific gravity of your aggregates. It's your specimen when you have already added asphalt in your mixture. Well, to find out GMB, you have a formula that is you will take the weight in air of your specimen, which is 3570, and you'll take the weight in water. So this is the formula to find out GMB. It's for compacted mix. So you have a value of we call that volume. Sorry, weight in air. We call that weight in water bed. So in submerged conditions, so you will find out the value of GMB, a value of 2.245. So now we can find out the value of BA. So you have a GMM value of 2.478. You have a GMM value of, sorry, 2.478, and you have a GMB value of 2.245. From that you'll get a value of 9.403. 9.403 percentage. We'll find out void in mineral aggregates. So what do you mean by that? So you have a total volume of these, and when you're saying that, you're finding out the volume regarding your mineral aggregates. So except this volume right over here, all the voids can be regarded as voids. So here, if you here to find out the void regarding mineral aggregates, you take the total volume, and for total volume, these voids can be regarded as void of air, and you have this void right over here. So, which is we call that like this way. So, VMA, BMA actually includes void of air and uh, void filled with asphalt. Sorry, yeah. What we can say that that Now we'll find out our problem, which is VMA, void filled with air voids in mineral aggregate. So you have a total volume of VMB, and you have some air voids, and you have some voids which is filled by asphalt, and you have another voids that is absorbed by your aggregate. So if you are trying to find out the voids in mineral aggregate, you have a total volume of VMB, and this total volume consists of these voids, which is void of air here, and this value, which is BFA probably, BF A probably, yeah, and another one which is VVE. So these three, BA and BFA, can be regarded as BMA, and it will be added by BVE, VM. So this is a VMA, void in mineral aggregate. So we have a formula to find this. So to find out VMA, we have a formula of 100 minus GMB over GSB PS. So here 100 is 100, and we have a GMB value of 2.245, 2.245, and you have a GSP value of 3.07, and that will be multiplied by PS. What do you mean by PS? PS is percentage of solids. In this math, our percentage of solid is 93% because 7% was bitumen, so it would be 93. From there, you will get a value of 31.99%. We will find out a void filled with asphalt. So our void is this portion, which is void of air. It was void of air, and except aggregate like this, these are my voids, and these out of these voids, you have asphalt of these portions. So if you divide the asphalt portion of your voids, and in denominator you will have the total voids. So this is the void filled with asphalt, and for that we have a formula, that is void filled with asphalt. We have it will multiply it 100, and we'll have BMA value subtracted by VA, and you have DMA over here, and you have a DMA value of 31.99, and void of air a value of it was 9.403, if I'm not wrong, 403, 31.99. So from that you will find a value of 70.6 percentage. So this is the math. Later design we'll do the design part of Marshall mix method.